Hi everyone, can you hear me? Hi everyone, good morning. Sorry for the delay. Like here, weather was not good, so there was some traffic jam because there was some tree that has fallen down on the road. So that is like because of that there was some traffic jam and I became late. So I'm sorry about it. Can you hear me now? Can you quickly confirm? Okay. So everything is fine or there is some delay? I really want to know this because there was some problem that I was getting last time. So I want to know if that is fixed or there is some delay. हाय गुरप्रीत, हाय खुशी, हाय ज्योति लक्ष्मी. तो ठीक है ना? So let's start. Okay. So things are fine, right? ठीक है. Okay. Okay. So we are going to start some practice questions on the data structures, and let me quickly introduce myself. I am Sachin. Those who are seeing me first time, I am co-founder and instructor at goclass. I finished my masters from IISc Bangalore, and after IISc, I have worked at a couple of companies, including Amazon. So at Amazon, I was working at applied scientist, and I also worked at Xerox Labs, and there I was working as research scientist, and I got AIR rank, like All India rank 33 in GATE. Okay, now in this, let me first tell you that what we are going to do in this particular series of session, right? So what we are planning, let me just write it down. So what we are planning is that we will be conducting live doubt discussion or live practice session for the standard questions only. Okay, practice sessions and that practice sessions will be from standard resources only. Sorry, there is some delay, I think. Standard resources, right? Which means I will not be taking any example that is not from standard resource. So all the examples that I will be taking is basically from the standard resources only. Which means I will be taking questions from universities like Stanford universities and maybe from MIT and maybe from Barclays, like that, right? So from these universities we will be taking the questions and we will be solving those questions live in the class. So I hope that agenda is clear to everyone. Now let's start. So in this session, again, we are assuming that, let me write my assumption, that we are assuming that you know the basics of the topic, right? So assumption is that we are assuming that you know basics, which means you can directly jump into the questions, okay? Basics of the topic. So suppose if I'm taking the linked list class, then I'm assuming that you know basics of the linked list. Okay, so I will not be teaching that what is a linked list in this class. I will not be teaching everything from the scratch. I will be directly picking up the questions. Now let's start our question number one. This is my question number one, and this question I have taken from this university UBC, and you can find this question at this link. Okay, so most probably I will be giving the link if you want to go to the link. Otherwise I will not recommend you to go over the link because I have already filtered out everything from those links and I am putting in the slides. Right, now let's start this question. What this question is saying, in this question let's assume that there are 2 pointers, one is jump, another one is next. So here what I'm doing is that this pointer, which is, let's suppose, jump, is pointing to something that is skipping one node, okay, and the next is pointing to the usual next node, which means this jump is pointing here and next is pointing here. I hope that is clear to everyone, that what jump and next are doing. Now tell me, is this a jump or next? This pointer is a jump or next? This pointer is a jump or next? So tell me, this pointer is a jump or next? This pointer is definitely a jump. Why? Because this is a jump pointer, then only it is pointing to something which is jumping something, right? So it is a jump pointer, right? Now this pointer is a next pointer. So there is a next pointer, there is a jump pointer. Next pointer is pointing to in the usual fashion, which means it is pointing to the next node. Jump pointer is pointing something which is skipping one node. So this is what link structure is given to us. And what they are asking in this question is that your code must run in constant space of time and they want to delete a node, okay? They want to delete a node and they are saying your code goes here. So there are 3 pointers that you are passing. One is target, another one is PRED, another one is like predecessor, another one is jump predecessor. So they are saying that target is a node that to be deleted, which means let's suppose that I want to delete this. Let's suppose I want to delete this. Then target is pointing here. If I want to delete this, then target is pointing here, right? So target will be pointing here. Now, where this predecessor will be pointing, PRED is a node that points to the target through its next pointer, which means that PRED is this, right? PRED is this. And similarly, they are defining something called a jump PRED, which is a node that points to a target through its jump pointer, which means through its jump pointer. So this is jump PRED. Jump PRED, right? So I hope 3 pointers are clear to everyone, right? So what is jump PRED, what is PRED, what is target, and what is your target actually? You want to delete this, right? I hope the objective is clear to everyone. So let me do what? Let me just copy this and let me paste it over the next slide so that you can have this structure in front of you while you are solving the question. Okay. So suppose that this is the structure that you have and you want to delete. Now can you tell me how, using either A or B or C or D, how you are going to delete this target? Okay. Just take 2 or 3 minutes, then or maybe 2 or 3 minutes will be too much, or maybe let's just take 1 minute and then answer me that what is the correct answer, right? So I hope the question is clear to everyone. Question is saying that we want to delete this target. Now to delete this target, if you want to delete this target at all, then what are the changes that you will be needing? First, you will be needing this predecessor to point to like this jump to point to this, or like what you will be needing. See, this jump should be pointing to what? This should be pointing to this node, right? So let me just write the final structure that we should be having after the deletion. So this is before the deletion. Let me go to the next page. This is before the deletion and this is after the deletion. So what I want and what is given, right? So there are two things. Let's suppose this is given and I want something like this. Maybe I want to delete this, then I want something like this, which means I want this next pointer to point to here, maybe, right? This jump pointer to point to maybe this node, right? And then I want this jump pointer to point to maybe this node, and I want this next pointer to point here. So if you notice, I want to change this. Earlier it was pointing to 123, right? I want to change this. Earlier it was pointing to 365, right? 365. And I want to, this is as it is, I want to change this also. This earlier it was pointing to 123, but now I want it to point to 365. Is this clear to everyone that what we want to do, right? Now can you write down the code? Let me know if there is any doubt. See, let me just go to the next page. Maybe I can clarify it more. See, I do have something like this. Maybe let me clarify it more. I do have something like this. Let me have a good diagram. So this is one node, right? And then this is another node, and then this is another node, and then this is another node, right? Like that I have like couple of nodes. Okay, this is another node. I want to do what? I want to delete one of them. Maybe let's suppose I want to delete this, right? And then finally I will be having something like this. Maybe I will be having something like this. Let me just write it down. I will be having something like this, which means this node will be deleted, and let's say that this is 1, this value is 1, this value is 2, this value is 3, this value is 4, this value is 5, and I'm saying that this is deleted. Now it no longer exists, right? And I want to delete this 3, which means this is still 1, this is still 1, this is 2, this is now 4, and this is now 5, right? That's the thing. Now I am saying to you is that you want to delete this 3, then what are the changes you will be needing, right? So you can say that this next pointer, see, this is predecessor, this is jump predecessor. I have not made this jump links, but I will made it, right? And this is target. Then you will say that wherever this predecessor or next is pointing, that should be changed, right? Which means this predecessor next should be point to what? 4, which means target next, isn't it? Are you all agreeing with this line or not? Tell me. See, this predecessor next should point to whatever target next is pointing to. Target next is pointing to, right? Do you all agree with this? Let me know if there is any confusion. So you understand these assignments, right? I mean, if I'm equating two pointers, then what does this mean? You understand this clearly, right? See, if I'm equating two pointers, suppose I'm saying, let me clarify this also. Suppose I'm saying there are two pointers P and Q, okay, like integer pointers only. And suppose that P is pointing here, and this is some variable X, and Q is pointing here, which is some variable Y. Okay, maybe this value is 5, maybe this value is 10. And if I write P equal to Q, then can you tell me what's going to happen if I write P equal to Q? It means that let this P point to whatever this Q is pointing to, which means that P will point to whatever Q is pointing to, which means P will start pointing here, and this link will get broken, right? This is what P equal to Q means. So whenever I am assigning pointers to each other, that it means that P will also point to whatever Q is pointing to. Now similarly, it means that predecessor next, which means this is predecessor, and this predecessor next, which means this pointer should point to whatever target next means this 4, right? So whatever target next is pointing to, which means it will start pointing here. Very good line, right? I mean, it will work like a charm. So it should be clear to everyone. Let me know if there is any confusion in this line. This line should be clear, right? Now let's understand that what else need to be done. See, now what do you want? Earlier let's just see what else needs to be done. Earlier this jump pointer was pointing to 3, but 3 does not exist anymore, right? See, these were the two pointers which are pointing to this 3, but 3 does not exist anymore. That's why this one should be pointing to this 4, which means I should be writing that jump of jump, which means I should be writing jump of jump, right? Or maybe this number jump predecessor, right? Yeah, this number jump underscore predecessor, like that's okay. I mean, terminology is okay. So this is jump underscore predecessor. This should point to equal to, this should point to what? Can anyone tell me? See, this jump predecessor of jump of jump predecessor should point to whatever this is 4, which means target next, isn't it? Is this clear to everyone? Right? So as you see here, that predecessor next should also point to target next, jump predecessor jump also should point to target next. So it should also point to target next, right? Now these two lines are okay to everyone, right? Now tell me what else you need to do. See, what I did, I made a change in this, I made a change in this, right? And now one more thing you need to change. See, earlier what was the case? That this was pointing here 4, but now this should be pointing to 5, which means that predecessor jump should be pointing to 5 means what? Maybe you can write in multiple ways basically. Predecessor jump, which means this pointer, let me write here, predecessor jump should be pointing to 5, which means it should be pointing to predecessor jump next. Maybe you can write like this, right? Predecessor jump next, or there are other ways also. See, it should be pointing to predecessor jump next, right? Predecessor jump next. This is also fine. Predecessor jump means this, and then next it should be pointing to 5. This is fine. Are there other ways? Yes, definitely. What are the other ways? Using the target. Yes, definitely. How? Using the target also you can say that predecessor jump, or like there are other ways, like you can also say predecessor jump, which means this pointer. Okay, are you getting, or like it is going to on the top of head? See, you have to be consistent. If you are just thinking that okay, let's just drop this session and maybe it is not useful or like that, you have to be consistent, and then only you will see that yes, these sessions are helpful. We are bringing this session to help you. If you are not if you are not consistent, then it will only harm you. So please be consistent in these sessions, and then automatically these sessions will help you, right? Okay, now what I'm saying, that predecessor jump, which means this pointer should be pointing to 5, right? Which means you can say target jump equal to target jump. That is also fine, isn't it? Target jump. So there are multiple ways, and this is one of the way. So let me just see. that predecessor jump should point to target jump. Yes. So A is the final answer, right? Let me know if there is any doubt in this. And A is the answer, and also if some answer is containing predecessor jump equal to predecessor jump next, then it is also the answer, right? Okay. Let me know any confusion. If there is any confusion, then let me know, and then otherwise I will move to the next slide. So I hope that is clear, right? Okay. If this is clear, then let me move. So we have just solved one question that is from UBC University. Okay. So this question I have taken from UBC University. If you want, you can check at this link. So we are going to solve only standard questions in this series. Okay, and this series will be not for just one subject, not for just one topic. It will be for entire GATE syllabus, and it will definitely help you immensely. Not just a little bit. It will help you very much. Like, just be consistent in these series. We are bringing so much of efforts to bring this series, so we are just expecting that if you be just consistent in this series, then you will see a drastic change after maybe 5 or 6 sessions, after just attending 5 or 6 classes. Now let's do one more exercise, which is basically reversing a linked list. Okay, and these questions, like this question, I have taken from this slide. Okay, University of Waterloo, UW. So let's just solve this question that I have taken from this slide. So the question goes like this. They are saying that consider the following code fragment, right? And then they are saying that front is pointing to the head of the linked list as shown in the figure. So figure is actually on the next slide. So they are saying the front is pointing to the head of the linked list, and then current equal to front. Okay, let me do one thing. Let me just copy this into the previous slide only, so that you do have both of them in the same page, right? Okay. So what they are saying is something like this. One second. Yeah. So what they are saying is this, that front is pointing to front of the list. That is perfectly fine. And then current equal to front, which means current is also pointing here. Current is also pointing here. Next equal to current next, which means next is pointing here, right? And then previous equal to null, which means like previous is some node which is not pointing to anything. So previous is null. Initially previous is not pointing to anything. So this is, let's suppose, null, and previous is pointing to null, right? Okay. Now, while current is not equal to null, they are saying while current is not equal to null, your code goes here. So you want to reverse the linked list, right? This is the job that you want to perform. Okay. So we all should be on the same page. So I hope you are getting the question. What we want to do? We want to reverse a linked list, right? Your task is clear. Don't worry about the solution for now. Task should be clear to everyone that what we want to do. We just want to reverse a linked list, which means, for example, that if this kind of scenario is given to you, right? If this kind of, which means something is pointing to here and then this is here. Let me ask you this question. Suppose you are given a linked list like this, and you want to convert into linked list h follow h, which means you want to convert like this, which means you want to say that okay, this current next should be pointing to whatever previous is pointing to, right? I hope this slide is visible to everyone. Then in this case, can you tell me what I should be writing? What I should be writing? If you are given like this and you want to convert like this, which piece of code can convert this kind of scenario to this kind of scenario? This is my normal question. Just I think one simple line can do this. What is that line? Maybe you can say current next should point to whatever previous is pointing to, right? So this simple line can change the whole scenario, isn't it? So I hope that is clear, that current next should be equal to the previous. Now tell me, isn't it we want to do? I mean, this is just a little idea. Let me call it a little idea. Okay, little idea towards the reverse. This is just a little idea that we want to do. So if given something like this, I can do somewhat reverse. I mean, not exactly reverse. This is not exactly reverse, but yes, somewhat reverse, right? This is somewhat reverse. Let me just call it somewhat reverse. Somewhat reversed, right? Now we want to apply the similar idea and we want to structure it a bit more formally, right? See, you are given this kind of a structure, and if you want to convert to this kind of a structure, you can just do in just one piece of line. Now what you need to do, you just need to apply this bit more structurally, which means you just need to say let's do it again and again. Maybe if I put this whole thing in a loop, which means if I keep on asking these pointers to previous to the point to the previous things, then my job is done, isn't it? I hope you all are agreeing to this. Okay, let's not worry about the complete solution. I'm not bothering about the complete solution. What's going to happen will happen. I'm just asking that given this structure, are you convinced with this little idea that somewhat we are able to reverse, isn't it? Please let me know if there is any doubt. So we are able to reverse, not completely, but yeah, in some fashion. Now what you want to do, you want to do it again and again. Maybe if you put this whole thing in a loop in some way, then it should work, right? Let me try to put this thing in a loop. Okay, so let me go to the next page, and let me just do what? Let me say that this is what I'm able to do, right? This is what I'm able to do, and now from here I want to reverse. This is like somewhat reverse, but I want to reverse it completely, right? So this is what I'm able to do, but I want to reverse it completely. So what should I be doing such that I can reverse it completely? Tell me. Let me just do one thing. Let me just say that I should be just, you know, to reverse this, maybe I should be having something like this. First of all, let me just say that this should point to previous, this should point to current, and then this should, like, whatever is the next node, right? Whatever is the next node, this should point to next. Let me first do one thing. Let me increment my pointers, isn't it? See, like, this was the initial structure that I have, and I am saying that just using just a one line, you are able to do somewhat reverse, which means you are standing here, okay, and you can ask it to point to here. Very easy, using just one piece of line. And then I'm saying that okay, this job is done. Now let's just increment your pointers, which means let's just go to the further nodes, isn't it? Okay, if that is okay to everyone, then I will proceed further. And for now, tell me, if you want to convert from this structure to this structure, then does next plays any role in this, or you can do it using just current and previous? Or tell me, or you have to use next. Do you have to use next here, or you can just do using current and previous? I think you can just do using current and previous, isn't it? So Khushi is saying linked list will be lost. No, Khushi, linked list will not be lost. There is a next pointer that is pointing to something, right? Linked list won't be lost like this. That's why we have the next pointer. Very nice observation. See, we have the next pointer because we can preserve the linked list. Okay. See, Khushi has made very nice observation. What she is saying is that if we do something like this, then it will lose my linked list. But that's not the case here. Fortunately, that's not the case here, because I do have something called as next pointer, which is preserving my linked list. Suppose I do not have a next pointer, which means suppose I do have something like this. Maybe let me say that I do not have the next pointer, right? Then tell me, is this okay idea? Is this okay idea to do something like this? No. In that case, I will be losing my complete linked list. In that case, there is no pointer that is pointing to this further structure, right? If I do something like this, then it is complete disaster, because there is no pointer that is pointing to this structure. That is why I will be having a next pointer. That is where next pointer is useful. I hope you got it. Okay? Now what I want to do, I can convert from this to this. Now I just want to move these 3 pointers. Can you write three lines of code that can move these 3 pointers? I mean, one line of code for previous, one line of code for current, one line of code for next. Can you write 3 lines of code that can move these 3 pointers? Maybe you can say that previous should be now pointing to what we can say, maybe current, right? Whatever current is pointing to, isn't it? Very nice idea. Yes, now previous will be pointing to the current. ठीक है, ये समझ में आया सबके कि previous equal to current लिखने से क्या हो रहा है? If I am writing previous equal to current, then what is happening? Then previous will be pointing to whatever current is pointing to. Now current is pointing to this node, so previous will start also pointing to this node. Okay? And then you have current, like you want current to point to this. So can you tell me what should I be writing here? Current should be, see, I am either writing CURR or current, like I hope that is fine to everyone, right? Okay, I should be consistent with my notation, but that is okay. I mean, we are not writing this on the compiler, so I hope that is fine, right? So current equal to, can you tell me what should be I writing here such that this current start pointing here? Very easy, it should be next, isn't it? It should be next. Should we take a little break, in the sense that should we take a deep breath and should we continue, or you are getting? See, बहुत ही आसान है. Like you were given something like this. I just said like can you just move this pointer backward? You said like yeah, we can do this using this line. And then I just ask you, can you do one more little favor to me, which is, can you just move these 3 pointers to the next set of nodes? Then you said, yeah, this is also very easy. Previous equal to current, current equal to next. Now tell me, what should I be writing here? Next equal to, can you tell me what should I be writing here? Next equal to next, maybe next, which means this next means, I mean, if you want, I can rename this. Next will work, but if you want, I can rename this. This means next means this is next, and next means whatever this pointer is pointing to, next should be pointing here, right? Yes, Ankur, that is right. So Ankur is saying that next equal to next. So these 3 pieces of lines can just do a little wonder, which means these 3 pieces of lines can just move my 3 pointers further. And my job is almost done. See, I can write this line, which is current next equal to previous. I can write this line here, current next equal to previous, right? This will do what? This will just make this pointer to point here. This will, sorry, okay, let me write it very clearly. This is current next equal to previous, right? So here these 4 lines will do what? These 4 lines will say, okay, current is pointing here, I mean this pointer is pointing here, and these three things are pointing here. And then what should I be doing next? Shouldn't I be doing current next equal to previous again? Current next equal to previous. Should not I be doing this thing again? Right? See, I started with this, then I did this. Then tell me, what should I be doing here? After these 4 lines, what should I be doing? I should be asking this pointer to point here, isn't it? I should be asking this pointer to point here. Is this okay to everyone? Which means I should be asking current, I mean this pointer, which means current next, I should be asking current next equal to previous, which means I am actually repeating the things. Right? I am actually repeating the things. If I am repeating the things, then why not to put these things in a loop? Let's put these things in a loop. Right? If you put these things in a loop, then it will do what? It will just make this shift 3 pointers, make this shift 3 pointers, make this shift 3 pointers, like that it will keep on doing, isn't it? So this is done. I mean, I now have a piece of code that can actually reverse a linked list. Yes, there will be a corner cases, which means that you need to take care of few things, which means whenever you are doing next, then you need to check whether next is null or not. There's a little things here and there you can do a check here and there, but that is okay, right? If you do these little bit checks, then things are working, right? So these 4 lines of code, if I put these 4 lines of code in a loop, then it will work like a charm. It will reverse a complete linked list. ठीक है, ये समझ में आ गया, राइट? है ना? तो अभी हम ये क्वेश्चन करते हैं फिर, है ना? या फिर हाँ, चलो पहले ये वाला क्वेश्चन कर लेते हैं. तो व्हाट दे आर सेइंग दैट you have current which is pointing here, I mean which is pointing to whatever front is pointing to, next is this, previous is this, ठीक है? And then your code should be written here, and let me do one thing. Let me write everything on the next slide. Let me just copy these things in the next slide so that you can have everything on the one slide. Okay, ठीक है, let me write these here. Now can you tell me what should be the answer? Just take your own time and tell me what should be the answer. Okay, which option is correct option, whether A, B, C or D? Just take your own time and tell me what is the correct answer. Actually, there might be some delay on the YouTube, which means what I am speaking that might be like live to you in few seconds. Maybe it is delay of 30 seconds or 20 seconds. That is always there. I mean, it is not my fault. It is nobody else's fault. This is how YouTube live streaming works. Okay. So if you are typing something, then I might see it after few seconds. Anyway, I hope that is fine to everyone. ठीक है? ये समझ में आ गया, right? So everyone is saying B is a correct answer. Okay, I little doubt it. I'm not 100% sure whether B is a correct answer. So let's just check whether B is a correct answer. So B is saying the next. Let me actually start from the A. Okay, okay. So A is saying the next should be pointing to whatever previous is pointing to. Next should be pointing to. Okay, this is somewhat reverse, right? I think I think we started current next should be pointing to previous. So current next should be previous. So yeah, B should be the correct answer. Current next equal to previous, and then previous and current both are moving further, and then next is also moving further, but only when the next is not null. Awesome. Like what can be better than B? आ गया ना समझ, मतलब इजी है, इतना कुछ टफ नहीं है. इफ देयर इज एनी डाउट लेट मी नो. सी करंट नेक्स्ट इक्वल टू प्रीवियस, दिस इज व्हाट वी हैव रिटन, एंड देन वी हैव सेड लेट्स जस्ट मूव all of these three pointers. So current I'm moving like this, previous I'm moving like this, and previous I'm moving like this, current I'm moving like this, and then before moving next, because since it is involving next, then I have to check whether it is null or not. So if it is not null, I can move this also, and then I will put this in the loop. And finally I will return like whatever, I mean previous or whatever, right? So I mean these checks are okay, these little checks are okay, but the whole code, the crust of the code is only this piece of lines, right? ठीक है, ठीक है. Okay, awesome. So you know that how to reverse a linked list, right? So let me just write here that what we know now, right? Now we know how to reverse a linked list. ठीक है, ये अब सबको पता है. But you do not know how to reverse a linked list recursively, which means using loop, using loop. But now maybe in today's session or maybe in the next session, I will tell you how to do it recursively, right? So still we need to know how to do it recursively. And this question I have taken from one university, I think, yeah, this university. I have taken from, I think this is University of Waterloo. So I have taken the question from University of Waterloo, okay, which is one of the top, top-notch university for, especially for machine learning. It is one of the top-notch university, okay. So now we know that how to do it using loop, but we do not know how to do it recursively, right? Using recursion. So this is still a question mark, which we will be addressing maybe in today's session or maybe in the next session. Okay. Okay. So B is the correct answer. Yes, very nice. Now, can you solve this GATE 2022 question, which is saying that consider the problem of reversing a linked list. To take an example, given a linked list below, and then finally you should be having this. Then which of the following is true about the time complexity of the algorithm that solve the problem in order of one space? So how much time you will be taking? I think you can do it in just one loop, which means like you are just traversing linked list once. So how much time you are taking? Which one is the correct answer? Can you tell me? I think we are taking order of n, right? So theta of n, yeah. So we are taking A. So A should be the correct answer. We can do it in just theta of n. How? We will be maintaining 3 pointers, and we will be doing what? We will be asking this 2 point here this 2 point here, and then we will be just shifting our 3 pointers. Then we will be asking this 2 point here, right, this 2 point here, and then we will be shifting our 3 pointers, and so on and so forth. So what we are actually doing, given a linked list, what we are doing, we are shifting the pointers, and we are making one link reverse at one time, which means we will say that okay, these are the 3 pointers I do have, right, and then I will say that why not reverse this, and then this is first step, and then let's move my 3 pointers here, right. So I will first reverse this, I will first reverse this, and then I will move my 3 pointers here. Then as a next step I will do what? So this is I mean like one iteration of the loop, and in the next iteration I will do what? Let me just write it here, and this is just one iteration, right? This is just one iteration. Okay, this is the next iteration, in which this is next iteration means like next time when loop is running, next iteration, in which what I will be doing, I will be saying that okay, I will just move this pointer, and I will just ask this pointer to point here, and then I will be moving further. See, initially I start in this case, in this iteration, I started with these 3 pointers, right? These 3 pointers which are pointing to these 3 nodes. Now I will do what? I will say that now I will be moving further more, which means I will be asking my these 3 pointers to point like this. So this is the first iteration, and this is the second iteration. That is how I will be keep on doing. Isn't it very easy? Right? So I hope that is fine to everyone. Yeah. Thank you, thank you, Mitesh. Okay. Now, in this case, like get in this, the question has been asked in grade 2022. You can say A is the correct answer. Very easy, right? Yes, this is just like a sliding window. Now let's move to one of the most interesting topic, which is recursion in linked list. Okay, this is very easy once you understand. Otherwise, it will be tough. So, are you guys ready for this topic? Because this is very nice topic, and it will require some little bit of attention for you guys. Okay, I will try to make this topic also very easy. It is actually an easy topic, but it requires your attention. So Avni is saying, sir, what do they mean by best algorithm? Okay, what do they mean by best algorithm? So here they are saying the best algorithm. Best algorithm means you should not be doing any stupidity, which means like you should not be saying that your algorithm. Okay, I mean if they say an algorithm that takes theta of n time, I mean see like the best algorithm means best which is possible. Like you cannot do better than that. Okay, they are not talking about your algorithm. You may do any stupidity, which means you may say that okay, let me just have a walk. Maybe I will go first here, then I will go here, I will go first here, and once I get tired, maybe I will do it maybe 10 times, 12 times, and because I'm maybe I want to lose some fat, and I will be just walking over the linked list. I will come back, I will walk over the linked list, I will come back, like that, right? And then once I get tired, I will do somewhat like this. So they are not asking about your algorithm. They are saying whatever best is possible, do it. Don't do any stupidity. I mean, am I convinced enough? Like ये समझ में आ गया ना? Like that was yeah, that was internet problem, and just now electricity has went away, so that is why there was a problem. ये अभी now everything is clear now. Okay. Okay, thank you, Mitesh. So, Mitesh, if you do not know, like, let me just introduce Mitesh since he have joined the class. So, I'm very much happy that he just joining the class. So, Mitesh is AIR 10 this year. Okay, Mitesh, who is just commenting, he is AIR 10, and just to let you know that yes, it is possible to get AIR 10 in even third year. Okay, in even just third year. I mean, it is almost impossible for the second year people who are thinking that okay, they have liberty of not doing hard work. They if they want, then okay, then they can skip the classes, they can leave the assignments, they can do whatever they want, right? Because they want to crack their gate in fourth year, right? Why third year? So like if you are having that kind of mindset, then you will never reach to the level that Mitesh has reached. Now Mitesh is enjoying his fourth year. I'm 100% sure he must be walking like a rowdy in his college, like, because obviously he has got AR10 in just third year. So it is huge thing. I mean, not a joke to get AR10 in third year. Like, congratulations Mitesh, and thank you for joining the class. Okay. Now let's move to recursion in linked list, which is very nice topic. Now before I move to recursion in linked list, I want you to visualize, okay, the linked list as a recursion itself, which means, see, this is what linked list look like. Okay, sorry, there is some power rainy season, and that is why I might not be visible to you. Anyway, my camera is on, but I might not be visible. Okay, so let's just continue. So just see this linked list, right? Just see this linked list. Now in this linked list, can you just see this linked list itself as a recursion? Which means, what is a recursion? Recursion means something which is a part of something. Now you will say that this is completely a linked list. Yes, this is a linked list, and the smaller things also linked list, isn't it? See, this smaller thing is also linked list. Now you will say that a smaller thing is also linked list. This smaller thing is also linked list. Now you will say that this smaller thing is also linked list. So linked list itself is looking like a recursion, isn't it? See, node is pointing to linked list. And I have taken this slide again, as I promised to you, that everything that we will be doing in this session, these sessions will be taken from standard resources only. So I have taken this slide from this source. Okay, this source, like from this, I just got to know there's a very nice visualization of linked list, which they are visualizing the linked list as a recursion itself. Like, what can be better than that? Okay, there is some buffering problem. That's what you are saying, right? One second. Hmm. Okay, now I think it is visible. So let's do one thing. Since there is a power problem, and I'm not 100% sure if this will keep on buffering or there will be no buffer. Let's continue this session tomorrow. Okay, and tomorrow I will make sure that even if power goes, then internet connection will be stable, so that we can run classes continuously. Okay, so we will continue the recursion in linked list tomorrow. Okay, so we will continue this recursion strategy tomorrow. I hope that is fine. Okay, just now power has come. I don't know, should I be continuing? Let's just continue. I'm sorry about it. Okay, let's just continue since I just got the power back. I'm sorry. Like, from tomorrow we will make sure that there won't be any disturbance, at least in the internet connection. So I will have a UPS for the internet at least. Okay. Okay. Let me just continue. Okay, give me a second. Let me connect to the Wi-Fi. Wi-Fi is just getting power up, so I will just connect after that. So this linked list recursive definition is clear to everyone, right? That how we are visualizing linked list as a recursion. Now some questions. Suppose that this is the question. In this question, like this question again I have taken from CMU University. You must be knowing CMU University, right? It is top-notch university. I mean, like it's just like a Stanford, MIT. This university is competing with these universities. CMU is one of the top-notch university in the world. Maybe I do not know the ranking, but it must be under 20 or under 10. CMU is that much level. Okay.